Okay, today we're going to talk about polar or graphs of polar equations. And I don't know if I'm going to put all the points, but I might put some of them in. Graphing it's going to be really fun with my Apple Pencil, but basically graphs of polar equations. When you graph equations in a rectangular system, you are banned by using an equation to set an equation. You are, what did I want to put there? I'm just going to say, you're just by using an equation to find ordered pairs. I have no idea what I wanted there. It's so weird. Plotting these coordinates as points was connecting them in a smooth curve. If we approach this same thing with polar equations, we would have, notice you have a different graph. You have an r equals cosine theta. These might, let me see, I need to get this as thin as I possibly can. Okay, because they are going to be tiny. All right, so the angles I'm going to use are 0, pi over 6, I'm going to use all the unit circle ones, pi over 3, pi over 2, I guess I'm skipping the 1/2, or the pi over 4s. 2 pi over 3, I'm just using from the textbook. 5 pi over 6, pi, and if you kept going, it would be 7 pi over 6, 4 pi over 3, 3 pi, yeah, that's a 4, really bad 4, 3 pi over 2, 5 pi over 3, yeah, I might just put 11 pi over 6, and 2 pi. Now, when I put these into my calculator and I go to my table, I'm going to get some values for cosine theta. So cosine theta, 0 is 1, and that I'm going to round that to 0.9, 5, 0, negative 0.5, negative 0.9, negative 1, negative 0.9, negative 4 pi, negative 0.5, 0, 0.9, and 1. Okay, so when we graph polar points, so we go to angle 0, and when it's positive, it goes towards it. Pi over 6 would be 0.9, so that might be really close to it, to the ring. Then pi over 3 would be 1/2. And 2 pi over 3, I'm not going to go towards it, I'm going to go away from it, maybe like that. So when this is all said and done, it makes a little circle like this, right here. And these points down here are where we're going away from the angle because we've got a negative value with it. And then sine's going to do the exact same thing, have not the exact same points, because sine's positive in the second quadrant and the first quadrant, so it's going to have more positives till we get down here into the 7 pi over 6. But I've got 0, pi over 6, pi over 3, pi over 2, 5 pi over, oops, I forgot 2 pi over 3, 5 pi over 6. I might stop doing them, just kind of giving us a decimal value, but you can plug this into this equation into your calculator in mode polar, and it will give you these values. And how this guy works out is at 0 be 0, at pi over 6 to be 0.5, and 1. I'm just going to kind of make the circle like that, okay? So those would be your parent functions for polar functions for cosine and sine. When we graph these in rectangular mode, we didn't have that circle, we had this. That's a really bad cosine graph. Let's make that a better sine graph there. Those were in rectangular mode. We are not in that mode. We are in polar mode, and that's the equation that we get. Okay. Example 2, we need to plug this into our calculator and figure out which of the 3 symmetries we have. When I download this from Google, from the internet, it does that double cosine and the double sine. But when I graph that guy on my graphing calculator, I see that this guy, so I'm going to type 3 plus 3 cosine theta, and it kind of, let me change my window. Let's go negative 5 to 5. Okay, it's kind of doing something like this. And that looks like that would be symmetrical to the polar axis. So symmetry to polar axis. So that's what you're supposed to be able to come in and be able to determine its symmetry. 2 plus 4 sine theta is going to give me ooh, I don't know if I can do this. We'll see if I can draw this guy. Nope, I totally messed him up. How about I go like this and then make a little loop? Okay, so that guy looks like he is symmetrical to the line y equals, or theta equals pi over 2. The last part is we need to be able to identify graphs, and math people we're pretty fancy when we name things. The first type of graphs, those are called circles. The second type of graphs, they look like that little one I just drew with the little loop in the middle. We call those limicons and or limicons, or if you have a French accent and you can say it correctly, then you might explain to Mrs. Heichman how you say it. These were fancy, they're flowers, but we're going to call them roses. And the last ones are lemniscates. And your job is to plug these in and to be able to determine what they are. For the first one, hopefully you notice that these guys all have an r equals theta equals a value and then cosine. So this should give you a circle, a very small circle. This one, if you notice on your flowers, which are your roses, they have the form A and then a number in front of theta. So this was going to be a rose, and it makes quite a few petals because cosine or sine actually doubles the number when it's even when you're graphing those. So pretty cool. Any others? No, I don't think so. That is it.